Hello ladies and gentlemen, my name is Mr. Dotson-Kelly. I am an Algebra 2 teacher from East Hartford High School. Today I'm going to teach you guys how to multiply and divide rational monomials. Before we get to the rational monomials, I want to first review how to multiply fractions. So we're going to look at a simple fraction, 3/5 times -2/9. The way you were taught this was multiply straight across. 3 times -2 is -6. And multiplying straight across here, 5 times 9 is 45. And then from here you can then simplify the fraction. Whenever you have a fraction, ladies and gentlemen, you always need to simplify it. You never want to leave it unsimplified. So looking at this right here, I recognize that both 6 and 45 are not divisible by 2, but they are divisible by 3. So 6 divided by 3 is 2. 45 divided by 3 is 15. Sorry, -2. -6 divided by 3 is -2. 45 divided by 3 is 15. And my final answer is -2/15. Now, that took a long time to get there. I combined my numerators and my denominators and I multiplied them together. I then simplified the fraction. There is a faster way to do this, which is the method we want to use to help us simplify our rational monomials once we get there. So I'm going to rewrite this exact same fraction, and I'm going to recognize the fact that when I am looking at this, I can see that my numerators are 3 and -2, and my denominators are 5 and 9. When I look at my numerators, I want to think to myself, what in my numerators can be canceled with something in my denominator? And when I look at those pairs, the 5 cannot be canceled out with anything in my numerator, right? If I just look at this right here, the 5 compared to 3 and -2, I can't cross that out with anything. But if I look at the 9, my 9 on the other hand can. It doesn't cancel out with -2, but it does cancel with 3. What I mean by canceling is, do they have a common factor? 9 is 3 times 3. 3 is 3 times 1. And these have a common factor. That common factor is just a single 3. And what's going to happen is that single 3, they're going to cross cancel each other. The remaining numbers are what I then multiply. So instead of multiplying by 3 to -2, I'm going to multiply 1 with -2, which gives me -2. And instead of multiplying 9 to 5, I'm going to multiply this 3 times 5. So that's 5 times 3, which is 15. And that's where I get these two numbers. And that is my final answer. If you notice, it's the exact same. It's a lot faster, it's a lot easier. How does this apply to monomials? Well, let's take a look at a monomial situation. Here's a rational monomial. 5y squared divided by 3 times 9x divided by 10y. Now again, I want to use this second method, this idea of cross-canceling, to help me out. This first fraction is simplified. I can't simplify it any further. This second fraction is also simplified. I can't simplify it any further. But when I look at the numbers diagonally of each other, I start to recognize that they have common factors. This 5 and the 10 have a common factor, as well as the 3 and the 9. And I can use that to my advantage. So let's think about this really quickly. This right here, I can rewrite all of this as 5 times y times y. And this can be rewritten as 2 times 5 times y. I'm going to go ahead and throw in a times 1 there as well. This is super helpful because now I can look for pairs of numbers, factors that can be divided out. So such as this, 5 divided by 5 is 1, and y divided by y is also 1. And I can do the same thing for my 9x and my 3. 3 is the same as 3 times 1. 9x is the same as 3 times 3 times x. Again, I'm looking for pairs of numbers that divide to 1. 3 divided by 3 is also 1. And what am I left with? In my numerator, I'm left with 1 times y times 3 times x. 1 times y times 3 times x, which is 3xy. And my denominator is 1 times 2. 1 times 2 is just 2. So I would end up with the fraction 3xy over 2. Now really quickly, to make things mathematically equivalent, we want to incorporate our knowledge about not being able to divide by 0. So coming back over here really quickly, let me rewrite this 5y squared divided by 3 times 9x divided by 10y. I am never allowed to divide by 0. It is called an undefined location. It is a constraint. I only have that concern here And the one question I ask is, what is the y value that will make this 0? So 10y equal to 0, divide both sides by 10, I end up with y is equal to 0. So ladies and gentlemen, y equal to 0 would make this a unoperational fraction. Okay, we would not be able to divide this out. So not only is this my final answer, I have to add on my constraints of y not equal to 0, because remember, we want our final answer to be mathematically equivalent to what we started with. Y is equal to 0 would give me a result of 0, but y equal to 0 over here would give me an undefined fraction. I can't have that. So this would be my constraint. I would stop myself here and say, okay, I cannot divide by 0, and I would have this as my final result. Okay, so this fraction is more simple than that, and it's mathematically equivalent. So after looking at this example, ladies and gentlemen, we're going to move on to dividing fractions. So again, we're going to start by a numerical review. So dividing fractions would look like this. If I had 3/5 divided by 4/5, I often tell my students that I no longer see division. I always see multiplication, because all division is the multiplication of a reciprocal. So the first number always stays the same, 3/5 stays the same. But this second part is what changes. This second part becomes times the reciprocal, 4/5. And now the nice thing about putting it in multiplication is we just saw and reminded ourselves how to multiply. Now we can multiply straight across. 3 times 5 is 15, 5 times 4 is 20, and I would then take that fraction and simplify it. Or I can use cross canceling. This is 5 times 1 and 5 times 1, and the 5's cancel out, and I'm left with 3/4 as my final answer. So using that knowledge, I would do that same exact step for rational monomials. So I have here r cubed s divided by t divided by rs cubed divided by t cubed. The first stays the same, r cubed s divided by t, but all of this changes. It becomes times the reciprocal, which is t cubed divided by rs cubed. And now I want to start looking for things that they have in common in my numerator and my denominator. This started with 3 r's, and I have 1 r down here. As a reminder, ladies and gentlemen, whenever you have a variable without an exponent, the implied exponent is a 1. So I actually have 3 implied 1's here. S to the first power, t to the first power, and r to the first power. I have 3 r's. I'm going to divide one of those r's out. So just to show you, r times r times r. And it's going to cancel out with this r. So one of these r's, we'll say this one right here, that r is going to cancel out with this r right here. And my numerator is going to be left with r squared. And you'll find that this is going to be true for all of these. So instead of rewriting it every single time, I'm now going to start subtracting the number of variables from that number. So there's 3 t's here, 1 t here. This t is going to cancel out with here, and it's going to be t squared instead. So t squared in my numerator. And last but not least, this s to the first power and s cubed, that's going to cancel out with one of these, giving me s squared in my denominator, and this would be my final answer. As a quick reminder, we want to talk about our mathematical constraints. So up here, mathematically, I would have to have t not equal to 0 because I can't divide by 0. So down here, I'm going to add in the constraint t not equal to 0. And additionally, I also cannot have s equal to 0 either. S cannot equal 0 either in order for this to be true. Thank you for watching my video, ladies and gentlemen. I hope that you find this useful. Take care, stay healthy, good luck.